Welcome to this explainer. Today, we're tackling a foundational concept that honestly still secretly trips up a lot of adults. We're going to be comparing and ordering real numbers using the number line. If you've ever found yourself second-guessing whether -3 is actually bigger or smaller than -6, or trying to figure out exactly where 3/4 sits among a bunch of whole numbers, trust me, you're definitely not alone. We're going to take what feels like abstract math and turn it into a highly visual, incredibly practical tool. Okay, let's dive into this. Right off the bat, I want to ask you a deceptively simple question. Which is greater, -2 or -5? Just think about it for a second. If you instinctively thought, well, 5 is a bigger number than 2, so -5 must be greater, just hold that thought. You are absolutely not the only one whose brain went there first. You see, this is a really common trap, and there's actually a fascinating psychological reason for it. Our brains are biologically hardwired to understand absolute quantities. Like, if you see 2 apples and then you see 5 apples, your brain instantly recognizes that 5 is more. It's a basic survival instinct. So when negative numbers enter the picture, that hardwiring kind of misfires. Negative numbers frequently trick our brains into thinking bigger digits automatically mean bigger values. Because, well, in the positive world, 5 is clearly greater than 2. But when we flip over into the negative world, the rules start to feel completely reversed, and it creates this sort of cognitive friction. It gets incredibly easy to get tangled up in the abstraction. What we really need is a reliable visual map to bypass that friction completely, so we never have to guess or rely on tricky mental gymnastics ever again. Section 1. Meet the number line. So what exactly is this map we're talking about? A number line is simply a straight, horizontal line that shows real numbers in perfect order, typically with 0 sitting right at the center. It's the ultimate tool for visualizing how numbers relate to one another. And that word, visualizing, is absolutely key here. Instead of trying to juggle abstract floating values in your head, you can actually see them plotted out in physical space. Actually, scratch the map analogy. It's more like a GPS. Think about how much easier it is to follow a GPS on your phone compared to someone just shouting turn-by-turn directions at you. The number line is that GPS for math. It takes concepts that are totally invisible and makes them solid, spatial, and perfectly ordered. Think of 0 as our home base. It perfectly divides our numerical world in half. From this center point, positive numbers march off in one direction, and negative numbers march off in the exact opposite direction. 0 is the absolute anchor for everything we're going to do today. Section 2, the golden rule. And this brilliantly illustrates the core mechanic at play here. On the number line, as you move to the left, numbers become smaller, more negative, and they are constantly decreasing in value. But as you move to the right, numbers become greater, more positive, and are constantly increasing in value. Left means less. Right means greater. That is the golden rule you need to lock in, and it's incredibly powerful because it's entirely universal. It doesn't matter if you're looking at +1 million or -50, any number to the left is smaller, and any number to the right is larger. You don't have to memorize 100 different complex scenarios. You really just have to remember this one continuous flow from left to right. Let's actually apply this golden rule to that initial puzzle that was tripping us up earlier. Imagine we're plotting -3 and -6 on our line. If I start at 0 and count left, I hit -3 first, right? If I keep going left, way out there, I finally hit -6. So based on our straightforward left and right rule, -3 is actually greater than -6, simply because -3 is located to the right of -6. By just locating them in physical space, the math literally solves itself. Section 3. Fractions and decimals. Now, what's really interesting about this is how the map completely demystifies fractions. A fraction like 1/2 and a decimal like 0.5 aren't two completely different mathematical entities. They're just different names for the exact same physical location on our number line. If you're ever confused by where a fraction lives, just convert it to a decimal, like noting that 1/2 equals 0.5, and it suddenly becomes so much easier to see precisely where it belongs. For example, consider 0.75. Where exactly does it live? Well, it's positive, so it's to the right of 0, but it's not quite 1 yet. It sits comfortably right there between 0 and 1. And because it physically sits to the right of 0.5, or 1/2, we know for an absolute fact that 0.75 is greater. These in-between numbers follow the exact same left and right rules as the whole numbers do. And hey, this works in the negative direction too. -0.5 sits exactly between 0 and -1. Since it's to the right of -1, -0.5 is the greater number. Whether it's a whole number, a fraction, or a messy decimal, they all answer to the exact same visual logic. Section 4. Comparing and ordering. Arranging numbers from smallest to largest, which we also call ascending order, is incredibly easy if you follow this simple, highly logical two-step process. Step 1. Take all the numbers you're given and just plot them as dots on your number line. Don't even worry about comparing them in your head yet. Literally just drop them onto the map. Step 2. Read the line from left to right. That's it. If you read those dots from left to right, you're automatically arranging them from least to greatest. You are letting the visual structure do all the heavy lifting for you. So the crucial point is how we write this down formally. These mathematical symbols, less than, greater than, are really just a shorthand for what our visual map is already proving to us. We use the less than symbol to show -2 is less than 3 because -2 is on the left. We use the greater than symbol to show 5 is greater than -5 because 5 is way over there on the right. And of course, we use the equal sign when 0.5 lands on the exact same spot as 1/2. The symbols aren't some cryptic code. They're just a quick way of pointing left or right. Section 5, Math in Real Life. Let's connect our visual map directly to personal finance. In the real world, positive numbers represent things like savings, income, and gaining value. Negative numbers represent debt, financial losses, or dropping below zero. Mathematically, owing $50 or -50 is significantly less than having $100 in savings. When you compare your debts and your incomes, you're quite literally plotting them out on a mental number line to understand your true financial health. And visualizing this can actually reduce financial anxiety. Instead of debt feeling like a vague, overwhelming burden, plotting it puts it into a clear, relative perspective. You can literally see exactly how far away you are from zero and track your progress as you move to the right toward positive wealth. And it goes way beyond just money. We intuitively use the number line all the time. Think about temperature readings. We implicitly know that -2 degrees Celsius is colder or physically less than 3 degrees Celsius. Think about distance and navigation. Tracking your position -3 kilometers behind the local baranga hall versus 2 kilometers ahead of it. Or even something as simple as calculating scores gained or lost in a competitive video game. In every single one of these visceral, everyday realities, we are using the exact same left-right logic we've been talking about. Which leaves us with this final thought. How can comparing and ordering numbers help you make better decisions in your daily life? Now that you have this ultimate visual map, now that you can precisely plot out debts, temperatures, fractions, and distances, how will you use it to navigate your world more effectively? Next time you evaluate a financial risk or compare data sets at work, don't just juggle the numbers in your head, put them on the line. Thank you so much for joining me for this explainer, and keep exploring.